in this video we have to draw the graph of two curves. First curve r is equal to sin theta and second r is equal to sin 3 theta. The first curve represents a circle with diameter 2 and second curve represents 3 radius. First we will discuss about the symmetry for both curves. You know, both curves are not symmetric about the initial line because when we replace theta by minus theta, the equation of both curves does not remain same. So we can say that both curves are not symmetric about the line theta is equal to 0. And when we replace theta by pi minus theta, the equation for both curves remains same and does not change. So we can say that both curves symmetric about the line theta is equal to pi by 2. Both curves symmetric about the line theta is equal to pi by 2, but both curves are not symmetric about the line theta is equal to 0 or not symmetric about initial line. These two curves not symmetric about the initial line, but both are symmetric about the line theta is equal to pi by 2. After checking the symmetric for both curves, we know find the nature of pole. For the nature of pole, you know, nature of pole we have to find the value of theta where r is equal to 0. For the first curve circle, r is equal to sin theta is a circle. We check for circle when theta is equal to 0, we will get value of r is equal to 0. It means pole lies on the circle. Our circle is passing through from pole, and we arrange a table for the first curve circle with a difference of 30 degrees. When theta is 0, r becomes 0. When theta is pi by 6, the value of r is 1, because sin pi by 6 1 by 2 and 1 by 2 multiplied by 2, we will get r is equal to 1, and so when r theta is equal to pi by 3, the value of r under 3, which is greater than 1.732. When theta is equal to pi by 2 at right angle, at 90 degree angle, the value of r is 2, which is the diameter of circle and which is the maximum value. And for the angle theta is equal to 2 pi by 3, the value of r is again under 3, and when theta is equal to 5 pi by 6, the value of r is 1. Theta is equal to pi, the value of r is 0. For this table, we will draw the graph of first curve circle. We will draw the graph of circle. To draw the graph of circle, we use this technique. We take, this is the center for circle and radius of circle, which is 1, because diameter of circle is 2. Now we draw the circle with radius 1, taking this point as the center of circle. This is a circle with diameter 2. After drawing a circle, we know find the natural code for the 3D flows. R is equal to sine 3 theta. R is equal to sine 3 theta. We find the natural code. Natural code means we have to find the value of theta where R is equal to 0. For this curve, R is equal to sine 3 theta, we have to find the value of theta where R is equal to 0. We check when R is equal to 0. When R is equal to 0, sine 3 theta is equal to 0. Sine 3 theta is equal to 0 implies 3 theta is equal to sine inverse 0. Sine inverse 0 means that and whose sine is 0. 3 theta is equal to 0 or R 3 theta is equal to n pi, because for every multiple of pi the value of sine function is 0. From here we get theta is equal to 0, and from here theta is equal to n pi by 3. For different values of n, for n we write for n 1, 2, 3, 4, 5 and 6. The value of theta is pi by 3 for 2, 2 pi by 3 for 3 pi, and for 4, 4 pi by 3. When n is 5, theta 5 pi by 3, and when n is 6, theta is 2 pi. These are all the intervals. For the different loops of the curve R is equal to sine 3 theta. These are the interval between them loop of curves are formed. So we will find where loops of curves are formed. To find where loop of curve was formed, we take a table with a difference of 30 degree. This is the table for loop of curve R is equal to sine 3 theta. We see when theta is equal to 0, the value of R is 0, and when theta is equal to pi by 6, the value of R is 1, and when theta is equal to pi by 3, the value of R is again 0, and when theta is pi by 2, the value of R is minus 1. When theta is 2 pi by 3, the value of R is 0. When theta is 5 pi by 6, R is again 1, and when theta is pi, R is 0. You know, maximum value of, for this function R is equal to sine 3 theta, the maximum value of R is 1, because maximum value of sine 3 theta is 1. For maximum value of sine 3 theta, which is 1, the maximum value of R is 1. We can see where is value of R is maximum. 1 is the maximum value of R. So we can say that at theta is equal to pi by 6, the value of R is maximum. At this angle, theta is equal to pi by 6, value of R is maximum. We can say that this is a line on which loop of curve is formed. And second line, theta is equal to pi by 2, on which the value of R is minus 1. And third line, on which maximum value of R is 1, is 5 pi by 6. We can say that line theta is equal to pi by 6, line theta is equal to pi by 2, and line theta is equal to 5 pi by 6 have the same values. Theta is equal to pi by 6, this is a line, theta is equal to pi by 6, this is a line on which loop of curve is formed. and second line theta is equal to pi by 2. This is the line theta is equal to pi by 2. And theta is equal to pi by 2, value of r is minus 1. Where should we take value of r is minus 1? We should take negative value of r opposite to the direction theta is equal to pi by 2. And opposite to direction theta is pi by 2, this is the direction. This is the direction which is opposite to the direction theta is equal to pi by 2. We should take r minus 1 on this line. After this, we see for the line theta is equal to 5 pi by 6. This is the line theta is equal to 5 pi by 6. On this line, loop of curve is formed. There are three lines on which loop of curve are formed. First line theta is equal to pi by 6, on which loop of curve is formed, and second line theta is equal to 5 pi by 6, on this line loop of curve is formed, and third line theta is equal to pi by 2. Opposite to this, we take r minus 1. So this is the line on which loop of curve is formed. For first loop, you can see that for first loop, which is on the line theta to pi by 6, this is the interval from 0 to pi by 3. This is the interval from 0 to pi by 3. From 0 to pi by 3 is the interval between first loop is formed. 0 to pi by 3 is the interval for first loop. We can draw the loop of curve between the interval from 0 to pi by 3 on the line theta is equal to pi by 6. By taking maximum value of r is 1. So we will draw the graph of first loop. We will draw the graph of first loop. You can see from both tables, except 0, 0, except pole pi by 6 from first table, the value of theta pi by 6 and value of r is 1. The point pi by 6 of 1 and point pi by 6 of 1 is a common point. It is a point where circle and 3 rows intersect each other. We have to find the point where they intersect. It is a geometrical way to find the point of intersection of both curves. We also can find the point of intersection by solving the equation 1 and 2. Mathematically, when we solve equation 1 and 2 by comparing both of them, we can find the point of intersection, but it is a geometrical way to find the point of intersection for both curves. You can see pi by 6, add pi by 6, add when theta is pi by 6, value of r1. Again in this table, when theta is pi by 6, r is 1, mean both points are same. We can say that this is a common point. Similarly, when theta is 5 pi by 6, value of r is 1. When theta is 5 pi by 6, value of r is 1 from both tables. Second point is, which is common point for both curves, is 5 pi by 6, 1. Value of r is 1 and theta 5 pi by 6. The point 1 and 5 pi by 6 is a common point for both curves. This is the point. We now draw the loop of curve. Loop of curve. We have to draw the loop of curve. This is the point. We take the value of sin 3 theta is maximum. We now draw the graph of a curve where they intersect. We take this is a point where sin 3 theta is 1. And here sin 3 theta is 1. This is the point. We take this is the point sin 3 theta is 1. We now draw the graph of a loop between the interval for the loop, which is from 0 to pi by 3. We will draw its graph. This is the graph for first loop. Similarly, we will draw the graph of second loop. For For third loop, you know where third loop is formed? For third loop is formed on the line theta is equal to opposite to pi by 2. This is the complete graph for both curves on same diagram. This is the point which is the point of intersection for both curves, and this is the chord graph for both curves.